thermostats up and down if nobody's in that building. You know, as long as they have the class schedule, they know when somebody's in there, then if they need to run the air conditioning, they do. When they can turn it off, then they also do. So it's the whole idea of these secondary markets now, which primarily right now are software services that are emerging, that are encouraged by this act. Another thing also, and we saw this also with the development of the internet, is the whole idea of middleware vendors. So you have some devices that speak older communication protocols, older languages in terms of how they provide management information. You've got these new high-speed digital things out here. You're actually going to see software providers who provide that protocol conversion in the middle, because not every network is the same. If I don't think of it at the time, when we get to the conceptual model of the smart grid, remind me to talk about the breakdown of the markets. Oh, I'm sorry. Yeah, enabling new products. So the other thing also, providing power quality. So again, if you think of fluctuations, the nice part about the United States is we have really primo quality power. And it doesn't matter if you're on the smallest rural electric cooperative or if you're here. You don't have to worry about burning up the transformers on your electronics because we provide high quality power. I know people who've taken their laptops on vacation to countries in Central America, and the machine doesn't work when they get back because of the variations in power quality. So what the Department of Energy said basically is, it doesn't matter how smart you are, if your power quality drops, you're going to miss the performance objective. Optimize asset utilization and operating efficiency. Again, you know, it's the idea of good, cheap, and fast. Pick two, you can't have three, right? Well, what they want to do is, you can throw a lot of money at this problem and solve it, but really, if you aren't providing efficiency, then you've really gained nothing. Because what happens is, as the power companies throw money at problems, who ends up paying for that? We do, the ratepayers. They just pass it through. So they're actually looking to establish efficiency and keep power rates low. A very interesting point on this, we're actually part of a group that bid on a contract for the state of California. And they listed their objectives were reducing greenhouse gases, increase the amount of renewables, you know, all of the things that you'd expect. But one of their objectives in terms of establishing their roadmap for electricity from now to the year 2020 was not keep it affordable. And so we pointed that out to them. We said, you know, affordable power, you know, if it's not one of your objectives, it becomes a barrier to everything else you want to accomplish. Because again, you can throw a lot of money at it and solve all these problems, but the ratepayers are ultimately the people that have to pay the price. Anticipate and respond to system disturbances in a self-healing manner. Anybody's power go out when we have the snowstorms here recently? Only one? Okay, two of us then. You and me. But the whole idea, and these two tie together, that and operating resiliently against natural disasters. The whole idea of, once you've got this intelligence in the system, that it can actually route and reroute power around, open and close switches automatically so that the fewest number of people are affected when you have some kind of event like we did here with the adverse weather recently in Washington, D.C. I mean, let's face it, when a snow-laden tree limb falls on a power line and breaks it, nothing you can do about it. But through that whole idea of opening and closing switches, you can actually reduce the amount of area, you can reduce the area that's affected. So you think about that 110,000 square miles that was affected back in 2003, you know, we may have been able to open and close switches and keep that very localized if the underlying grid had been intelligent. So that's this should be one of the huge benefits that we get. But the other thing also is, because now we mentioned on smart meters the whole idea of two-way communication. If you aren't getting a communication from a meter, now that's self-reporting the outage. So if you take a look at what happened after that, a lot of people had to break out their cell phones and they had to be dialing the power company, and then you go through 7 menu options, press 7, press 4, press 0. You finally get to the point where you can enter your phone number and then the power company knows you have an outage. They don't necessarily know who all is affected, but at least you are, and it goes into a database, and then they start to figure out how to fix it. Well, the intelligent grid, the smart grid, will actually be, in addition to self-healing, it will be self-reported, so that the power company knows, you know, and they can compare that to their architectural diagrams, and they can get a better idea of where the outages are occurring, so that they can go out and fix them more rapidly. So. That's what the Department of Energy envisioned, and that's where the robustness comes from. Section 1305 of the Energy Independence and Security Act is the whole idea. Remember I mentioned about the way the internet is built, it's based on standards. So this is where the whole notion of standards comes into play in terms of the Energy Independence and Security Act. So they put in charge of that the National Institute of Standards and Technologies, which is exactly where it should be. And I've highlighted some of the things here that they cited that they should try to achieve. It's the whole idea of this managing interoperability of smart grid devices, enable all electrical resources, including demand-side resources, to contribute to an efficient, reliable electricity network. So you go down through, and then they come and say, solicit input and cooperation from the National Electrical Manufacturers Association. So NIST now is in charge of the standards effort based on this law. So what they had to do is they had to establish, just like we did with the internet, the whole method for identifying standards that we can deploy today, what standards exist that need some adaptation that we can use, and then what needs to happen in terms of new standards work so that we achieve these performance objectives that DOE has spelled out and that's in the early part of the law. So NIST has been charged with this, and the first thing they did is they got 2,000 of us together over a series of 3 meetings, and we went through the whole process of identifying where are the areas we all agree, where are the areas where we need work, and so they came up with this framework and roadmap for smart grid interoperability standards. So this is a great document. And if you go to nist.gov/smartgrid, they have links to this out there. And this really does lay everything out. So if you have any questions about what's ever going on with the smart grid, by all means consult this document. This is your handbook for smart grid. We went through 3 previous editions. We had release 1.0 that came out on January 25th of this year. And what they did is they came out and said, okay, there are 25 standards that we, the industry, all agree on are shovel ready for smart grid. So as long as manufacturers build to these specifications and utilities employ them in the electric grid, then we're actually starting to move toward that whole idea of smart grid. In addition to these 25, they identified 50 additional standards that have the characteristics they're looking for. So the whole idea of resilience and incorporating all of these other interoperability features, those 50 standards are out there, and so these are areas where we need to, some of them are very young. One of our standards, in fact, is on that list. And what we need to do is just through more deployments as we bring out some more features, maybe a few revisions on these standards, these will soon be able to graduate and they can become approved standards for smart grid. And lastly, they said these are the 15 priority areas that we need for new standards activity. That was later expanded to 17, but in a month. Yeah, this is just like, you know, we've established the Constitution and then, oh, we forgot a few things. So that's the Bill of Rights there. So they later expanded it to 17, and these are the next priority areas. So basically, if we're going to maintain this momentum in terms of deploying the smart grid, you know, these are the next things that we really need to do. Now, it's very interesting. So the folks at NIST, they actually appointed the national coordinator. His name is Dr. George Arnold. And when you hear any speech by Dr. Arnold, he measures the level of effort to achieve smart grid in terms of the number of standards that must exist. If you take a look at what happened in the internet, again, as an example, there's a couple thousand requests for comments that constitute the internet. Some are obsolete, but you know, 2,000 or so. You take a look at what happened with the digitization of the telephone network. There's another 600 or 700 standards there. So as we went from the old analog, plug the wires phone switching system to fully digital system, there's like 600 or 700 standards there. So if you take a look at the number of standards that are going to have to exist in terms of smart grid in order to achieve this full maturity, we got 75. We may need a few hundred of these things. So we got quite a bit of work ahead of us. Those 17 priority action plans that I had previously mentioned. The first thing they did, we talked about smart meters previously. You remember that from section 1305? Yes, sir.
Quick question. You talk about generating all these standards, but for the industry, what do they have as in, I guess, why would they want to go follow the standards? Just to become, is it the law to follow the standards, to build to the standards, or is it just to be compatible with everybody?